Today I want you to be able to solve problems involving the fundamental counting principle, permutations, and combination. Now I've just put in what the fundamental counting principle is here, but it may be easier to see what it is with an actual example. We have a table here and we want to make a yogurt parfait, and you have to choose one flavor of yogurt, one fruit topping, and one nut topping. And we want to know how many choices there are. Well, this turns into a pretty easy problem. What you need to do is you make one blank for each of the choices you have, which would be whether you have a choice of flavor, a choice of fruit, and a choice of nuts. So I'm just going to put a blank for each one of these. This is for the flavor, this is for the fruit, and this is for the nuts. Okay, so you just count all these up. There's 2 here, 1, 2, 3, 4, 5 here, and 1, 2, 3 here. So you just put these in the blanks, 2, 5, and 3, and we just multiply them together. So 2 times 5 is 10, times 3 is 30. So there would be 30 choices. Okay, the next one is a password, and we can see that we have 4 digits. Now usually when you have digits talking about the numbers 0 through 9, unless it's otherwise specified. Usually they're single digits. So a lot of people think this is 9 choices, but there's actually 10 choices if you count 0 and then 1 through 9. So there would be 10 choices here per digit. Okay, so we're followed by 2 letters. All right, now we have some restrictions here. So we know we have 4 digits followed by 2 letters. So we have 1, 2, 3, 4 blanks for the digits, and 1, 2 for the letters. So these are letters. I'm just going to put D's under here. The letters A and Z are not used. So there are 26 letters in the alphabet. So that leaves us now with, that means we have 24 left. Each digit or letter may be used more than once. Now this is really important. You need to pay attention. It says it may be used more than once. The word not, N-O-T, 3 little letters, can completely change that problem, and I'll show you in just a minute. How many unique passwords are possible? Well, if they can be repeated, I have 9 choices for this blank, 9 choices for this blank, 9 for this one, and 9 for this one. Each digit or letter may be used more than once, so I can have 24 here, and I can have 24 here. And then you're just going to multiply all of those together. Okay, and then I'm just going to write what that is after I multiply all of those out. It's 3,779,136. Now, if I would change this and say that they cannot repeat, so let's just put no repeats over here. And you can't see that. Let's see. No repeats. P-E-A-T-S. Okay, so I still have 4 digits. 1, 2, 3, 4. And I have 2 letters. 1, 2. Okay, so we can't repeat. So if I choose the number 0 for this one, I can't for this one. So I only have 8 choices. Whatever 2 I choose for here, I can't use here. So that would mean 7. And then we would have 6. Out of 24 letter choices, I have 24 choices here, but let's say I choose a B here. I can't choose a B here, so that's 23. Same thing here. We're going to multiply them all together. And once I multiply those out, I have 1,669,248. So quite a bit less if I can't do repeats. All right, the next thing I want to go over is a permutation, and that is a selection of a group of objects. And this should say, this says were, but it should say where. So we could just where order is important, and this is really important. You'll see why in just a few minutes when we do some examples. If you have a title, an award, a place like first, second, or third, awards like best, worst, titles like president, vice president, anything that distinguishes one person or one thing from another, so it's assigned to a person, then order is important. So example, if I have 3 people and I assign an office to each one, and then I switch the people up again, so for here Pat's the president, and here Sam's the president. So same 3 people, but I'm changing their title or their office, then I have a different group. So that's a permutation. You're switching them around and it results in something different. Okay, in order to understand permutations, first we have to talk about what a factorial is, and you have a factorial button on your calculator. The factorial of a number is the product of the natural numbers less than or equal to the number. So all that means is, let's say if we want to do 4 factorial, that equals 4 times 3 times 2 times 1. So you just multiply those all together. So the number is less than or equal to the number. Now 0 factorial is defined as 1, which we just have to do that because if we would end up with 0 factorial in the denominator, our problem would be undefined. So this is what a permutation looks like. The number of permutations of 7 items taken 3 at a time. So we would do 7 factorial. We would be going 7 times 6 times 5 times 4 times 3 times 2 times 1. And then it would be over how many, the total that we have. So this is the total. And this is the number you are choosing. Now you have a button on your calculator that's a permutation button, and we'll go over that. Okay, the next thing we have, and this is where it gets a little tricky, is choosing between, let's do an example first. How many ways can a student government select a president, vice president, secretary, and a treasurer from a group of 6 people? So we have 4 offices, and these are different, and that's important. So 4 different offices. That means we're going to use a permutation, and you can denote permutation with a P. So, and what you do is you put the total number on the left. So we have a group of 6 people, and we're choosing 4 of them with different titles. So it's a permutation, and then you can just put that in your calculator. You'll do 6P4. And depending on what type of a calculator you have, it should look like this on your screen. So if I have a group of 6 people, I'm choosing them 4 at a time. There are 360 ways to do that. So we'll put 360 here. Okay, so this implies order is important. Now, how many ways can a stylus arrange 5 of 8 vases? This implies order. They're from left to right. So order matters. That means we're going to choose permutation. So again, I have 8 vases total. I'm writing that it's a permutation, and I'm choosing 5 of those in order because I'm putting them from left to right. So on your calculator, you would choose 8P5, and you should get 6,720. Now, combinations and permutations sometimes get confused. So the most important thing to do, the math is easy, but the wording is what you need to look at. Is order given or implied? Combinations, a grouping of items in which order does not matter. If you rearrange the order, you still have the same grouping. And this is how it's figured out mathematically. You take the total number, and then the number that you're choosing, factorial, multiplied by the total minus the number you're choosing, factorial. Oh, and the numerator is a factorial as well. So if you're choosing 3 people from a group of 7 to serve on a committee, how many ways can you do that? Well, we have not given order to any of the 3 people. We're just choosing 3 of them. If they change their seats, if they move around, they don't have any titles, so there's nothing really to distinguish one from the other. So that's why it's called a combination. We have 7 total, so we're going to go 7C3, and you want to be careful when you put that in your calculator. Make sure you're using a combination instead of a permutation, because there's quite a difference in what you'll get for those. So we're going to enter that in 7C3, and you should have 35. Now, if you would do 7P3 or permutation, you're going to end up with, let me see, write this down here, 7P3, you'll end up with 210. So be real careful. Now, there are 12 different color cubes in a bag. Now, the colors are different, but that doesn't mean when you pull them out, they're going to be any different. How many ways can Randall draw a set of 4 cubes from the bag? So let's say there's 12 different colors. Let's say we choose yellow, red, green, and orange. Okay, the first time I choose yellow, then red, then green, and orange. Okay, let's say the second time I choose the same ones, but I choose them in a different order. I still have the same cubes in my hand. Doesn't matter what order I chose. So this order does not matter. So we're going to say this is a combination of 12 C4. Okay, so 12C4, there are 495 ways I can do that. Okay, so difference between permutations and combinations. If you notice here in the numerator, ways to arrange all the items, that's the same. And the denominators, ways to arrange the items not selected, ways to arrange the items not selected. The difference is, in the denominator here, you have to multiply it by the ways to arrange selected items. Okay, so big difference between permutation versus combination. Order matters here. When you switch things around, it matters. And order does not matter here. Okay, a few questions for you to try.